How about we talk about a little bit of Python, shall we? Today we're going to be talking about the for loop. What did we talk about last time? The while loop. All right. So let's take a step back, because all you have in your toolbox right now is the while loop. So let's do a programming challenge, shall we? So user enters their name, John Smith. And then what your program is going to do is it's going to step through the string that they entered and print out each character by itself on a line, listing their name vertically. So what's this program going to contain? What's the first thing you're going to do in the program? Input the name. Great. And the name is going to be in what? An integer, a float?
That's going to be a string.
It's going to be a string. Congratulations. You have learned some Python. This is fantastic, baby. I'm so thrilled. Okay. So there you go. The name's in a string. Now what are you going to do? Remember, you want to print out the names vertically.
Should I take each character of the name, like identify each one first?
Gotcha. You move from what? Right to left to right, or right. So, how are you going to do that? I think the concept is good. Congratulations. How are you actually going to pull that off in Python?
Square brackets, but 0 colons to however long the name is.
Well, okay. So you bring up a good point. How are we going to figure out how long the name is?
Length.
Length. So len, and that'll give us a cool. Fabulous. So now we know it's like 10 characters long. Cool. And we know we want to go stepping through it, like you said, fantastic. Not wrong. How are we going to do that?
Use some magic coding.
Magic coding. Fantastic. Dun, da, da. Oh, wait, we don't have any magic coding. We can only use what's in our toolbox. What should we use to process each character in somebody's name? A while loop. Fantastic. That sounds good. Now, a while has what? A condition and then some statements, right?
Yes.
So for this conditions, what are we going to use?
Counter and
Cool. So a counter. Counter sounds good. What should the condition with the counter be? If blah blah.
While the counter is less than or equal to
The length. Okay, that sounds so. We'd start at like 0, which would be the first location in the string, and we would go to like the length of the string, right? In which particular case it would actually be less than the length, right? We're doing some subtleties on this. So the first position on the string is identified by what number?
0.
0, right? And the length would be like 10. So we'd want to do like 0 through 9, right? So just do that, okay. And then when we go into the actual loop itself, what are we going to do?
you're going to
Print.
the character, like you do like the
Print the character that's in the 0 position, and then do line character 1.
Well, print character, I'm 100% with that. That's fine. But what position am I going to print? Counter. Wherever I happen to be, right? And then I'm done, right? Cool.
You did your counter +1.
Well, each time I go through the loop, I want to print how many characters? 1, right? Then I go back and do the next one. And we want to do like a line each. After you've gone, like this one we do up and down, right? So maybe the code would look something like, oh, I don't know this. So username is input, enter your name. So that's a string, right? There's our counter that we were talking about, right? I equals 0. Well, by the way, I sort of sucks as a variable name, by the way. Well, I is less than length of the username. Letter equals username, square bracket I, square bracket, print letter. I equals I plus 1. What kind of output are we going to get? Enter your name, John Smith, and we're going to get John Smith. Make sense? The power of the while loop. Hot diggity. Hey, the for statement. For is another way of doing the exact same thing that the while statement does. It's a looping construct. Okay? It's a little bit different though. Okay? For letter in state name, for example, colon, do whatever else comes after it. What we got going on here? So we've got a variable, and then we've got what they call a container. What's a container? A container has stuff in it. and you're going to go stepping through the container for all the stuff that's in the container. If it's a string, what kind of stuff is in the string? Characters, exactly right. So you go stepping through each one of the characters in the string, right? Okay, a for loop is used to iterate over the contents of any container, which is an object that contains or stores a collection of elements. In the string case, it's characters. The string is a container that stores a collection of characters. All right. Now we just did this one, where we're going to print out somebody's name vertically, right? And we did it using a while loop. Well, let's try doing it using a for loop. What would this look like? So username equals input, enter your name. That's pretty familiar ground. We're comfortable with that. For letter in username, print letter. Does this make sense? We're going to go stepping through username, starting at the left, going to the right. And what we're going to get is exactly the same thing. John Smith. Huh. While and for seem to do exactly the same thing. An interesting point, though, is this less code? I mean, the other one was like 6 lines, and this is like 3 lines. I mean, it's not that big of a deal, but it is less code, potentially. What's the difference between while loops and for loops? In the for loop, the element variable is assigned state name 1, 0, 1, 2, and so on. In the while loop, the index variable is assigned to 1, and so on. So remember, we have the letter in blah, blah. That's what's getting done here. Over here, it's the index variable that we're using to step through the while loop, right? Range function is a very, very important part of the for loop. So count-controlled loops that iterate over a range of integer values are very common. I'd like to do this 10 times, I'd like to do it 100 times, I'd like to do it 10,000 times. We do that all the time. To simplify that in Python, Python provides what's called the range function for generating a sequence of integers that can be used within the loop. Here's what the code looks like. For I is in range 1 through 10, print I. Now there's a little gotcha that's going to come back and bite you hard when it comes to a range. Would you like to know what it is? Or do you want to find out on your own? So the trick with the range is it doesn't make it to the biggest value. It won't do this for 10. It'll do it 1 through 9. It will actually do it 0 through 9. Oh, actually in this case 1 through 9. But it won't make it to 10. So if you wanted to do this range from 1 to 10, you'd actually have to say range 1 to 11. That's exactly correct. First argument of the range function is the first value of the sequence. Values are included in the sequence while they're less than the second argument, which means 10 doesn't make it. You can do the same thing with while and for loops. For I is in range 1 through 10, print I. What's that going to print out?
1 through 9 inclusive.
That is exactly right. So this will print out the digits 1 through 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Ooh. Meanwhile, we'll go over to our while loop. I equals 1, while I is less than 10, print I. I is equal to I plus 1. What's that going to print out? Trick question. It's going to print out exactly the same thing, right? We see the digits 1 through 10. 2 different pieces of code that do exactly the same thing. And once again, we have to be very careful because we're not actually going to make it to 10. That's a subtlety. It's going to come back and bite you. It's a good thing in some cases, but it is a little subtlety that can be a little bit of a surprise. Okay? So stepping out. By default, the range function creates a sequence in the steps of 1. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and I'm all done. But it turns out you can change that. You can make it step in different amounts. Okay? And the way you do that is you add one more value when you're doing your range function. So starting value, less than or equal to, less than maximum values, and the stepping function. So remember when we did that problem where we wanted to sum all the odd numbers? Remember that one? Yeah, it's starts in the butt, right? Okay. Well, it turns out that in this case, we could have used a for loop, but we could have used a step of 2, and we would have gone through automatically. each and every odd number. That would be fantastic. Okay? So here we go. If we have this code for I equals range 1, 10 with an increment of 2 for an I, what we get is 1, 3, 5, 7, 9, poof, all the odd numbers. Make sense? Loop challenge number 2. Oh hey, remember this one? To create a program to print the sum of all odd numbers between A and B inclusive. And obviously we're going to be doing a for loop. Alright, so if we were going to write this program, let's think about this for a brief moment. What's the very first thing that we would want to do? Great question. Yeah, so we got to get A and B. Poof! Got A and B. We're going to assume that they're what type? Integers. Great, we got 2 integers, A and B. Poof! Now we want to print all the odd numbers between A and B. So what's the very first thing we have to do?
Figure out if A is even or not.
That is exactly correct. So just like last time, and how are we going to do that? Modulo, right? We're going to modulo 2 it, and if the result of a modulo 2 is 0, it means the number is, and if it's 1, it's odd. Alright, so we can figure out if A is even or odd, right? Cool. Now we know if A is even or odd, we have A and B. What are we going to do now? Careful, we're on dangerous brand new territory here. Interestingly enough, a loop, and remember we're going to use the for statement, right? Cool. So where are we going to start our for statement? Well, A if it's odd, right? And if it's not odd, then we're going to start it at A plus 1. Okay, cool, fantastic, wonderful. And remember that for loop has to have a starting spot and an ending spot. And what's the ending spot going to be?
B. B or B minus.
So we have sort of an interesting question. How far should we go?
Depends on whether B is even or odd.
It does sort of matter, doesn't it?
You either stop at B or B minus 1.
Because let's think about it for a moment. If B's odd, and we said go up to B, what would happen? Would we make it? We wouldn't include B. We'd be screwed, right? So what do we want to do? So do we have to figure out if B's odd? Yeah. And if it is odd, then what are we going to do? We'd have to go one farther, right? If it's even, we don't care, because we don't have to get up to B. We don't, whatever, we're not right. All right. Well, that seems like an easy thing to do. Let's put this to look like a grammar code. All right. This should all look incredibly familiar, because it is pretty much familiar. Get A and B. Determine if either A or B is even or odd using modulo. So there'll be a 0 or a 1 in there. Calculate the value to start counting at. Is A even? If it's 0, then start counting at A plus 1. If it's odd, then start counting at A. All right, that makes sense. Well, hey, look at this. This is brand new. Calculate the value to finish counting at. If B is even, then the end value is B plus 1. If B is even is equal to 1, I think that means that it's I, so thus it's 1. Else, end value is B. And then we have our main loop thing. Answer equals 0 for loop counter in range, start value, end value, increment by what? 2. Answer equals answer plus loop counter. Print loop counter. And then display answer to user. Here's what the answer is. Alright? Let's give it a run and see how it goes. What should our start? Well, we'll do something small. So let's do 2 and 11. Alright, so we wanted to add up all the odd numbers between 2 and 11. So what do we get? We got 3, 5, 7, 9, and 11, right? Yes! And we add them all up, we got 35. Does that seem like the right number? Sure. Alright. So a little different one on this one is because of the way the for loop ends up, we had to take a closer look at that b value, right? We had to figure out if b was even or odd, and if it was odd, we had to make the for loop go one more so that we included the b value, right? Question?
Wouldn't B plus one have worked regardless of whether that was?
Unfortunately, you were exactly right. We didn't have to calculate that. Just make it plus one, and if it gets sucked in, it gets sucked in. If it doesn't, it doesn't, right? Sort of figured that out while I was standing up here. We're just gonna go with it. It was a nice job figuring it out, though, right? No matter what, it works, correct? But you are correct. We really, for everyone else, we really didn't have to figure out if B was even or odd. The point was made that as long as we just went one beyond B and included it, then if it was odd, it'd get included, and if it was even, it'd get skipped over, and life would be great. Make sense? But it was pretty cool code, no matter what. All right.
Negative numbers.
Should we run it for -2 and -11?
Yeah, so you have to have negative 11.
Negative 11.
You have to have negative 11 first.
You know? It's an interesting point, right? It's not very sophisticated code. It's not really set up for this, is it? Find out. Or maybe we'll get a negative 35. Well, it didn't like that, I'll tell you.
You did what you did first.
Alright, so you say, okay, maybe we start at -11.
Oh, no, no,
So go to -2.
top portion.
There we go.
Yo.
Ah, okay.
Hold
So it turns out that that range function actually has a couple of secret identities. So let's take a look at it. You can use the range function with a single argument. Okay? When you do, the range of values automatically starts at 0. Sounds like something like cool kids would do, right? It's going to start at 0 anyway, right? So for I in range 10, what that means, and then print out hello, we'd actually print out hello 10 times. But wait, I thought we didn't go up to 10.
It's a 0.
So we're really doing 0 through what?
9.
Which is a total of?
10.
Exactly. Alright? Cool stuff. Very, very simple stuff. There's no rocket science here whatsoever. But this is the kind of stuff that at midnight trips you up. Why is it not working? It starts at 0. Oh, it doesn't go all the way up. Oh yeah, now I remember. Oh, I forgot that one. Ah yes, the many different forms of range. So there's 3 different forms of range. Let's just quickly go over them so they're stuck in your brain. First one is range where it has a single number, 5. What that means is it's going to start at 0 and it's going to go up to 4. That's exactly right. The 2-value one, for I in range 1 to 5. It means it's going to start at 1 and go up to 4. Fantastic. For I in range 1, 11, and 2, it means we're going to start at, and the next number is going to be 3. And we're going to go up to 5. We'll actually go up to 10. But we'll only print out. Well, actually, we'll sort of step. Yeah. But we're cool. So just understand, you got 3 different flavors of range, depending on what you're trying to do with your for loop. Okay? Describe the steps necessary for finding a solution to the problem. Okay. Hey, we're pretty familiar with this one, aren't we? Put 10 grand in the bank, you get 5% interest per year. Question is when's the thing going to double? I think, yeah, okay. So we've done this one like 100 times before, right? But we've not done it with the for loop. So let's take a look and see what the bank problem would look like if we used the for loop.
I don't know why I feel like code fine.
Wow, that's a short piece of code, isn't it? What we got going on here? Rate is equal to 5%. Initial balance is 10 grand. Target is 2 times initial balance. Obtain the number of years for the computation. So we changed it up a little bit here, but that's okay. Number of years equals int, input, enter number of years. So remember, this is my cool new format, right? So I'm asking for the input, number of years, and that'll come in what format? Float, integer,
That comes in as a
string. We put an int on it, pow, we got an integer stuck into num years. Cool. Print the table of balances for each year. Balance equals initial balance for year in range 1 to number of years plus 1. We really want to go through the whole should match. Figure out what the interest is, stick it into the account, and then print out year in balance. Print the results. The investment doubled after X number of years. Yeah, I'm not sure if that's actually going to work, but we'll give it a shot anyway. Enter number of years 15. So we printed out year number 1, it's 10,500. Went up to year 15 where it was 20,000. The investment doubled after 15 years. And I'm playing a game here because I know it doubles after 15 years. Apparently I rewrote my code a little bit. But you get the gist of it here, right? So this is a for loop produces output. We did it, the range was from 1 to number of years. In this case, number of years was 15. And not only that, I apologize, it was 1 to number of years plus. And we did that so that we would actually go how many times? The total time, right? In this case, 15. Cool. Count iterations. Yeah, so once again, the whole gist on this one is when you're dealing with for loops, you have to be very careful in how many times your for loop is actually going to execute. This requires just a little bit of brain power on your part, okay? So treat this as a cautionary note. Should you start at 0 or should you start at 1? Okay, always an interesting question. Remember, if you start at 0, your loop is probably going to go one more time than you had anticipated. Should you use less than or equal to b or just less than b as your termination condition? Bigger deal when you're dealing with while loops, right? Following loops are executed b minus a times. Start with a, while I is less than b, do it all, okay? For I is in range a to b, okay? b minus a is the number of times you're actually going to execute that. You can go through strings. I think that's pretty common, not a problem with that. But if you're going to go through a string, you want to start at 0. Because remember, when you're talking about locations in a string, the very first location in the string is always going to be at location 0. The plus 1 problem. Yay. So how many times is the loop with symmetrical bounds executed? Int I equals a, while I is less than or equal to b, I equals I plus 1. How many times are we going to go through that? It's actually b minus a plus 1. Okay? And once again, it's not rocket science, but this will come back and bite you 100 times, right? So you have to take a very close look at how many times your for loop is actually going to execute. When a is 10 and b is 20, how many times does this loop execute? 11. Yeah. Right? Not 10 times, but 11 times, right? In Python, for a loop, the plus 1 can be quite noticeable. Okay? So if you're actually going to do the plus 1 and you're doing for loop, it becomes real clear because you sort of document it. You put the plus 1. Otherwise, it's just going to butt up against it, right? So for that purposes, for loop can be your friend. Loop challenge number 3. All right, so what I want you to do is read in 12 temperature values. Okay? And I want you to display the number of the month. So we'll assume that 1 is January, 2 is February, so on. With the highest temperature. For example, the average maximum temperatures for Death Valley are in order by month in degrees Celsius, 18.2, blah, 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 blah. So why don't we write a program that sucks these in and figures out the maximum one. So let's think about this program. What's the very first thing we're going to do with the program? Inputs. Wrong. Ha, trick question. So what are we going to have to do? Because we've got 12 values we want to read in, right? So we can't suck in an input right off the bat. I mean, we could. That would be weird. We could actually read in 12 values and do something with it. But what we're trying to do is experiment with for loops here. So, what's the first thing we're going to do? Do we know how many times we're going to loop? 12. Seems like we should set up a for loop to loop how many times? 12 times. Fantastic. Okay. So that would be while loop variable is in range from 1 to 13 would do it,
Or 0.
or 0 to 12. Right? Starting 0. Okay. Cool. And once we're in the loop, what do we want to do? Input. So we'll get a temperature, right? And then what do we want to do with that temperature? We want to figure out if it is the highest. Okay, so we want to compare it to what?
The previous.
Whatever the previous highest one was, right? And if this month has the highest one, what do we want to do with the month value?
Make this month the highest.
Exactly, right. And maybe that's it for the rest of the program, and nobody else will have a higher one, but let's go ahead and check it out. All right, well, let's see what this would look like if we put it into code. Alright. Initialize highest month, the only input that we have to put. Highest value, next value, float input, enter a temperature value for month number 1. Well, here, okay. I feel a little bad about this. So apparently what I decided to do was grab the first month before we started the while loop. Really just to initialize the variable. I could have set it to 0 if I wanted to, but I grabbed the first value. Highest month is equal to basically 1, and month number 1 is which month? January. Fabulous, great. We now ask for the remaining 11 months of temperature data and measure to see if the entered temperature is larger than the current one. So, for current month is in range 2 to 13, right? Because that means it's really going to go from 2 to what? 12. Exactly. Next value is float input temperature, enter temperature value for the month. If next value is greater than highest value, then highest value is equal to next value, and highest month is equal to current month. So basically, if the value that you just entered is larger than the previous highest temperature, we're going to save both the value and we're going to save the month. And we'll do this how many times? 11 times, right? 11 shots, see how it goes. And then when we're all done, we're going to go ahead and check the highest temperature occurred in month 1. Okay. Seems like that should be pretty reasonable to do. So which month is going to have the hottest? What's our hottest value going to be? 1.7. Go. Our friend the for loop helping us out, right? So there is a secret form of the print statement that has not been revealed to you until now.
Blue.
Okay? Concept is when you print a print statement right now, what happens is you automatically at the end of that print statement go to the start of the next line, right? It doesn't have to be that way. You can cause a print statement to stay on line, which is interesting because in your last homework, when you're printing out, for example, the address, had you known about this, what you could have done is you could have printed street address and used comma n equals quote quote. Then you could have printed state and used comma n equals quote, and you could have printed what? City, state, and zip. And then when we printed zip, you could have not included that, and then you would have gone to the next line. So you have the ability to stay on the same line of output if you append comma n equals quote, your print statement. Simple enough, right? Now you have the power in your hand. Include this argument to the last print function. We indicate that an empty string is to be printed after the last argument is printed, which basically means stay on the same line. The output of the next print function starts on the same line at the same spot where the last one left off. Big deal? No, not a big deal. Handy? Could be handy. Loop challenge number 4. All right, I want you to create a program that's going to print out the following table. Tables consist of the first 4 power values for the number 1 through 10. So 1 through 10, going up and down, and I want you to print out 1 to the 1 power, which would be what?
1.
2 to the 1 power, which would be
2.
Then squared, cubed, and whatever you call it when it goes to the 4th power. Make sense? What's that?
Yeah,
After cube is
You want to come up with a cool new name for it? Why it's a cubic or whatever. Okay, gotcha. All right, so that's our goal. So we want to make a beautiful looking table. That's good. Is that too important? Okay. See, our vocabulary is a little bigger. So when we're going to do this, what are we going to need? How would we start this program? So how many rows are we going to have?
10.
How many columns are we going to have?
4.
I'm smelling double loop. But whatever, you tell me. So how are we going to start this program? What's the first statement in our program going to be? For loop. Okay, well that sounds like a good idea. So what shall this for loop control? Is it going to control the number of columns, or is it going to control the number of rows? Rows! Okay, let's come with the for loop that's going to control the number of rows. How many rows do we want? 10. So we should say for what?
1, 2.
Well, for some variable is in range. We just put 10.
Yeah.
And that's going to give us what values?
0, 0, 9.
Okay, that's cool. We can also put 1 through 11. And then we wouldn't have to do anything funky with either add 1. We don't have to use it. Just create our power, right? Okay. So cool. So now we got our rows taken care of. Inside of the rows loop, what are we going to want to do? We want to take care of our what?
Columns.
Columns. Okay, so how are we going to do that? We're going to use what kind of statement? A for statement. We're going to say for some sort of variable is in range.
1 to 5.
How many columns do we have?
1 to 5.
How many columns do we have?
4.
Okay, so we're coming up with the for loop that's going to control our columns. So we're going to say for some variable is in range what?
1 to 5.
1 to 5. That would work, right? All right, let's see what this looks like. I think we got the heart of it right there. Let's take a look and see if we can figure out what the details are. All right. Please notice our top with a lovely comment. N max is 4. X max is 10. Oh, okay, so that looks like rows and columns. Print the table header. Oh, this is so cool. For n in range 1 to n max, which is the number of columns, plus 1. Okay. Print, that's a lot of stuff. It prints out actually really header. Okay, cool. Print table body for x, lousy variable name, in range 1 to x max plus 1. X max, of course, being the number of rows. Print the x row in the column. So now here's our second for loop that we talked about, right? For n in range 1 to n max, which of course is the number of columns, plus 1. Print if x star star n, right? So we're raising it to the power. And n it's actually the column number, right? And it's the column number. Let's give this a shot and see what it looks like. It should be pretty simple. It's basically a for loop inside of a for loop, right? Woo! Look at that! We got this whole here fancy formatting, x to the 1, x to the 2, x to the 3, x to the 4. Boom, and then we got our power table, right? Bam. Not too shabby, I say. And we have one for loop that produces our 10 rows, and we've got one for loop that produces our 4 columns, right? Nested inside each other. That for loop stuff's pretty powerful, isn't it? Not bad. What else can you do with for loops? You can count matches with strings. So using the fancy new is uppercase method, you can count the number of uppercase characters in a string if you care to do so. Coincidentally, there is a lowercase one. So you can count the number of vowels in a word if you want to. You'd say, hey, can I find a match in this particular string of A, E, I, O, U? If so, increment the number of vowels that I have. Just quickly little examples. Finding all matches in a string. Once again, using the for loop, you can go stepping through any sequence of characters looking for a match for whatever you happen to have, right? Finding the first and last match, that's pretty standard stuff. All right, let's talk about what's in your Python toolbox now. We started with print, we added math, strings, IO, if else, element. We did while last time, and this time we've added the for statement to your toolbox. So now you have 2 different ways to do loops. And for and while are actually pretty simple. They are actually interchangeable. You can use them in sort of the same situations and stuff like that. However, they are different. And they're generally, one of them is better suited to something that you're doing. You use for a lot more when you're actually doing specific counting. You use while a lot more when it's sort of a condition of how long you should keep looping. It's your call. You cannot go wrong. You can use them interchangeably. You won't have any problems with it whatsoever. What we covered today, we did the for loop. We talked about the range. And we talked about using loops to process strings. What are we going to do next time? The heart of Python. Lists. We're going to start it next time. You're good to go, and I will see you on Thursday.